Hi, how you doing? No camera, but much craziness. This is a thought experiment, or a thought invention. I've been thinking recently about the problem of trying to make an object which is a closed system able to propel itself. So this is the topic of like the EM drive, and also the Mega Drive, not to be confused with the retro game console, right? Both of these are seeking to figure out ways to create an engine that is able to propel an object through space through pure energy without needing any kind of propellant. Now, if you can do this, it's very significant, because that means that we could create rockets that are able to power themselves almost indefinitely, as long as there's power which could be generated from a reactor. It becomes possible to travel all kinds of distances without accelerate. In fact, you could accelerate to a good fraction of the speed of light over a period of time, and so on. So this is kind of a big deal, right? And here's the thing that was troubling me, though, about this, is there's in theory no way of doing this. I mean, if you try to create a system where there's some kind of mass in here, and we move the mass, sort of like move the mass this way, then what's going to happen is the whole ball, the whole sphere, will move this way. So yes, we have, therefore, because of the action and reaction thing of Newtonian physics, equal and opposite reaction. So it is possible to move it, but only so far. I mean, when this slams itself against the end here, then that's as far as you'll be able to move it, right? So in order for something to move, it needs to have contact with something in the outside world. And this is, of course, why, if the nightmare scenario, if you're an astronaut in space, and you've lost your tether, you'll go spiraling off, and you can't change your direction, you can't slow down, you're doomed, no matter how much you wave your arms about. But the weird thing is that you can change your orientation. So although, you can't change your position of your center of gravity, you can actually rotate yourself by swinging your arms around. Or if you want to do it more precisely, what you do is you set up a gyroscope, basically. So if I have a spinning disc in here, and then I change the angle of the disc, it's going to cause the whole sphere to sort of rotate in response. So it's weird, isn't it, that there is a way to do angular, to create an angular rotation from a closed system, but not a linear change. An angular acceleration is possible, but a linear acceleration is not in a line. The center of mass can't do it. So and I find that rather troubling, frankly, because, well, angular physics and linear physics really are very similar. So anyway, I was thinking about it, and now it got me thinking, what if it was inspired by the Mega Drive? Maybe there is a way, if we could change the mass of an object by some kind of magic. So what I'm going to do is try this here. Okay, is this going to work? Right. Oh, there we are. So imagine that I have two masses. I take one and take the other, and these two masses are connected by, you know, a bar like this. Obviously there would be a centre of mass as a result, and if we span this, it would spin around that centre of mass. So this really doesn't help too much in creating a translation, unless we were able to modify the masses. So this is some mass here, and there's a mass here, and we make them the same mass. What would happen if we had some magic mechanism that would allow us to make the mass heavier or lighter in some way? And then we change the mass as it moves around. In fact, what I propose in this thought experiment, caveat, I'm pretty sure this isn't going to work, but it's kind of an interesting thought. So here the mass is a bit bigger and there is a bit less. And just for the sake of demonstration, we're going to make it so that either side of this line is going to flip. So when this arrives here, past that line, it's going to become negative, and when this one comes over, it's going to become positive. Okay, above the line it's going to be heavier, and below the line it's going to be lighter. Now if we did that, this is what would happen. So we're going to put the plus here and the minus here, is that the centre of mass is going to be shifted. So what this means, of course, is that the thing here is going to rotate around the centre of mass. So just before it crosses that critical line, we might end up with something like this. Line it up. Okay, but when it reaches this point, these flip. So this now is going to be we're going to have the plus being here, and the minus is minus going, there we go, right, the minus is going to be here. Well, what this means is that the centre of mass is now shifted. So in effect, when the flip happens, it's moving the centre of mass, but it's doing it without moving anything. This is important, because if inside the closed system you try to actually change the centre of mass by moving weights around, the moving the weights around is going to cause a shift in the sphere that will cancel out whatever you will gain from changing the centre of mass. It cancels itself out. But if you had some magic way of changing it, like we have here, where there's just like, okay, we're going to change the mass from a higher mass to a lower mass, it's going to pop by this magic the centre of mass to here. So now it's, because it's going to be closer to the heavier mass, and as it continues spinning, right, because these things are spinning like this, as it continues spinning, it's now going to be spinning around here, which means that you will eventually, when it comes back to the beginning, oh, how unfortunate it doesn't fit. So I tell you what, I will just copy this to here, and you'll get the idea, because I will just copy that, and what we can do is shift it over. So hopefully you see what is going to happen. Is we've moved. The whole thing has in fact shifted to the left. Now, maybe that would be easier to see if I put this down here. So, you know, we go right. It shifted. The whole thing has shifted to the left. We were here. We're now here. And if we carries on doing this spinning, this thing is going to translate itself. And there you've got, from an internal energy source, through the magic of changing the mass, internal energy source allowing an acceleration to be applied to the to an object, in theory. So all we need to do then is figure out, okay, how do we change the mass of an object? So interesting thing is this old equation. You can see this coming. So another thing I've often thought about, and some research on the internet seems to indicate that it's true, is that if you take a battery and charge it, you know, a rechargeable battery, if the battery is fully charged, it's going to weigh a little bit more, because the battery has potential energy, and the potential energy does cause a difference in mass in the system. Okay, now I'm quite sure that what I'm saying here is going to be flawed, but I'm having fun, so, you know, let me have my fun. If you could say that, if that's the case, we could say that we could use energy as a way of changing the masses of these, you know, increasing, reducing the masses of these masses as they spin. So I was thinking, oh, well, you know, we could charge a capacitor. That would be the same thing. A fully charged capacitor must weigh more than an uncharged one. Oh, the effect is really small, though, unfortunately, because, you know, if E equals mc squared, then, you know, m must equal E divided by c squared. So when you charge your battery up, the energy you put into the battery doesn't translate to very much mass. This c squared is of course a very big number, and that's why nuclear explosions are very you know, big. Equal mc squared, c squared very big. You know, fully convert 1 gram of matter to 1 gram of matter to energy. You take that would be 0.001 times c squared, which unfortunately is a very big number. Yes, I don't know, so it's 300 kilometers per second, so approximately, isn't it? 300 kilometers per second. So that's 300,000 meters, right, per second. Oh, hang on, 300 kilometers per second. I'm going to get this right. That feels a bit small. Speed of light. When in doubt, look it up. Yeah, I was out by a factor of 1,000. It's 300 million meters a second. So that's better. So we have 300 million meters every second, and then I need to square that. Where's the square? There's the square. So this is a very big number, and then we're going to, but we're only doing a gram, so I can divide it by 1,000 because that's it. And so there we have 90 billion, 90 American billion, 90 trillion. It's a very big amount. It's a big number. So unfortunately, that's the problem here. But I don't care because I'm just doing this in theory. You know. So how might we do this? I mean, you know, charging and discharging a capacitor, and then I thought, well, you know what? How about we do this, right? What we do is we take, here we go. We take this thing. I'll just make another one here. So what we do is we take this, and we make, because you know what's going to happen, because whenever you want to sort of do experiments with crazy stuff, you know, use magnets. So yes, that's very predictable. We're going to end up with magnets. So here we'll put a plus and minus and minus and plus on the end of these. North and south, I suppose. All right, you know, I said minus and plus. Let's use north and south. So we say this is the north pole, this is the south pole, this is the south pole, and this is the north pole of this magnet. And you know, perhaps what I could do, I'm just going to put, just to make the point, just put a magnet here. All right. But I suppose we could make a horseshoe that goes all the way around, but this should be sufficient to demonstrate the idea, the crazy idea. So we do, there we go, we have magnet here, and this one we'll put the north here and the south here, and on this one we'll put the south here and the north here, and then we spin this really fast. And what I'm thinking is, right, and as I say, this is a thought experiment. I'm not saying that this would work, but in theory, this mass here, close to the magnet, it has a very high potential energy because it wants to repel each other. This here has a very low potential energy because they want to attract each other. And so we could say that this has an M plus and this M minus, causing the center of mass to shift up a little bit. And so that's the idea. Spin this really fast, and you might find there's a very, very small, probably couldn't even be measured, acceleration of the object, even though it's inside a closed system. How's that for a crazy idea? Let me know what you think, he says, as though he has a channel where people leave comments. But maybe you feel like it. Maybe you leave a comment this time. Gosh. But it'd be really nice. Anyway, if this worked, wouldn't it? I mean, that would be cool. Unlikely, but cool. If you're interested in the topic of this, as I said, there is the EM drive, which I think has been proven or has not been confirmed. The latest theory is any effects that were observed from it were probably due to the electricity flowing through the cables to power the thing, interacting with the Earth's magnetic field. That was the probable reason for that. I mean, the problem with these things is they're very small effects, and so it's very difficult to measure and get definitive proof. The other one is, as I said, the mega drive. And that's actually quite a cool story, because the key scientist behind this is like 80 years old, and still hanging in there with this. But he's got funding from NASA as well, and it looks like there could be something in it. And this has to do, it's vibrating a piezoelectric diaphragm. So it vibrates from an electric field, and it's done at a very specific frequency that the idea is interacts with the fabric of space-time to create a kind of wave that pushes the thing along. So check that out. Take care. Bye.